Good morning, Morgan, and good morning to any of your friends that have joined us for this video. So we're going to continue talking about exception handling, and I actually have a little bit of code that we're going to run to kind of show you this. This bit we can work with. The other stuff, this is a little too difficult to try and write code for, because you need a really big program for that. And I don't feel like that. But anyway, so let's just dive in and let's get through this reading, shall we? All right.
Python TV50 8.3 Handling Exceptions. It is possible to write programs that handle selected exceptions. Look at the following example, which asks the user for input until a valid integer has been entered, but allows the user to interrupt the program using Control-C or whatever the operating system supports. Note that a user-generated interruption is signaled by raising the keyboard interrupt exception.
All right. So we're taking this code and we're putting it in a program. We're going to run it, and it's going to be interactive. And if we give it something other than an integer, it's going to give us this error message. Otherwise, it's going to go ahead and it's going to work. All right. Now let's go ahead and continue our reading.
The try statement works as follows. First, the try clause, the statements between the try and except keywords, is executed. If no exception occurs, the except clause is skipped and execution of the try statement is finished. If an exception occurs during execution of the try clause, the rest of the clause is skipped. Then if its type matches the exception named after the except keyword, the except clause is executed, and then execution continues after the try statement. If an exception occurs which does not match the exception named in the except clause, it is passed on to outer try statements. If no handler is found, it is an unhandled exception and execution stops with a message as shown above.
You're going to want to memorize all of that. Okay? Because if you understand this, then you'll understand how this works and your life will be easier. Let's continue.
A try statement may have more than one except clause to specify handlers for different exceptions. At most, one handler will be executed. Handlers only handle exceptions that occur in the corresponding try clause, not in other handlers of the same try statement. An except clause may name multiple exceptions as a parenthesized tuple, for example.
Yeah, what I find interesting about this is when you do an exception, usually you want to do something. And all this thing is doing is passing it along. I must be missing something. Anyway, let's go.
A class in an except clause is compatible with an exception if it is the same class or a base class thereof, but not the other way around. An except clause listing a derived class is not compatible with a base class. For example, the following code will print B, C, D in that order. Class B, exception.
All right. Is that it? Oh, we still got some more. Let's go.
Note that if the except clauses were reversed, with except B first, it would have printed B, B, B. The first matching except clause is triggered. The last except clause may omit the exception names to serve as a wildcard. Use this with extreme caution, since it is easy to mask a real programming error in this way. It can also be used to print an error message and then re-raise the exception, allowing a caller to handle the exception as well.
All right. Okay, so this is the catch-all right here. Okay. Is there anything more? Oh, we still have some more. Oh my God, how much is there?
The try. Except statement has an optional else clause, which, when present, must follow all except clauses. It is useful for code that must be executed if the try clause does not raise an exception. For example.
All right, now remember what we were talking about earlier. Okay, so when you go in here, the first thing it does is it checks to see if this exception is true. And then if it passes, it will execute everything in between the try and the except. And then it punches out and executes what comes next. And what comes next? The else statement. Okay? And that's when it realizes that there was a problem. And you know what? I'm confusing you, so we're just going to stop right there and keep going.
The use of the else clause is better than adding additional code to the try clause because it avoids accidentally catching an exception that wasn't raised by the code being protected by the try, except statement. When an exception occurs, it may have an associated value, also known as the exception's argument. The presence and type of the argument depend on the exception type. The except clause may specify a variable after the exception name. The variable is bound to an exception instance with the argument stored in instance.args. For convenience, the exception instance defines __str__, so the arguments can be printed directly without having to reference .args. One may also instantiate an exception first before raising it and add any attributes to it as desired.
Well, that was a mouthful, wasn't it? And here we go. Here's the code that does all of that. All right. I think we're almost at the end. There's just one last little bit, and then we can run some code.
If an exception has arguments, they are printed as the last part, detail, of the message for unhandled exceptions. Exception handlers don't just handle exceptions if they occur immediately in the try clause, but also if they occur inside functions that are called, even indirectly, in the try clause.
All right. Okay, that's handy to know. All right. With that, we're going to go ahead and we're going to run some code. All right. I'm not going to bother showing you the program code because it's just copied right out of the document. But we hit enter, we executed the program, but because it's interactive and it needs input from the user, it's paused. So the computer program is still in the memory of the program and it's kind of waiting. It's waiting for us to give it a value. Okay? And what does it want? Well, it wants a number. So we're going to give it B. Boom. Oops. Not a valid number. All right, let's give it 6607. Oh, it doesn't like the decimal point. Isn't that interesting? Well, what if we just give it a regular? What if we give it a -6? All right, it didn't like the negative number, but it didn't like the decimal number. Anyway, this is an excellent way of showing you how to check whatever information or data a user is giving you. It's like a filter, or I don't know what you want to call it, but just put that in the back of your mind. This is the kind of thing you want to do when you have a program that's interacting with a user. Whenever the user gives you data, you want to check the data, and this is how you do it. All right. So with that, go out and enjoy the rest of your day.